Okay, so today, lesson 5.5, this is about modeling with exponents and logs, which essentially just means that we are going to need to be writing some equations using our points. So we're going to be writing an equation or an exponential function in the form y equals ab to the power of x, whose graph passes through the points 1, 6 and 3, 54. So we've done things pretty similar to this in the past, where we're using points to substitute into a function and then kind of just solve for our other values. So that's going to be the same thing we're doing here. So if I have 2 points, that means that I have an x and a y value for each point. So for this one, x would be 1 and y would be 6. For the next point, x would be 3 and y would be 54. And we're going to be substituting those values into this function. And for these ones, I'm always going to want to start with the second point. So if you want to write that as a note for yourself, you can. Start with the second point. So how that's going to look is if I have y equals ab to the power of x, the y for the second point is 54 equals ab to the power of x for the second point is 3. And then we're going to do the same thing, but for the other point. So the y value for the first point is 6 equals ab to the power of the x for the first point is 1. So here we have our two functions where x and y have been substituted in. Okay, now the next step we're going to do, which this might seem a little kind of strange, but this is how we're going to solve it, is we're going to divide the first function that we've written divided by the second. So we're going to divide these by each other. So if I look at the left side of the equation, this 54 minus 6, 54 divided by 6, that would give me 9. 54 divided by 6 is 9. On the right side of the equation, a divided by a would cancel out. So those two would cancel each other out, a divided by a. But then for the b's, this b to the power of 3 divided by b to the power of 1, when we divide these variables, we subtract the top exponent minus the bottom exponent. So b to the power of 3 divided by b to the power of 1 would be b to the power of 2, or b squared. So now I have 9 equals b squared. Well, this is an exponential equation that we already know how to solve. This is, we could use the square root property here that we used in our last unit, where I could take the square root of b squared and the square root of 9 to simplify this. The square root of 9 is 3, and the square root of b squared is b, so that would give me that b equals 3. Once I know that b equals 3, I can substitute that into one of these two equations. It doesn't necessarily matter which one I substitute in. Either one will work. Either one I can use to find the right answer, but it's going to be easiest if I pick the one with the smallest exponent. So I'm going to pick this one, 6 equals a to the power of, or ab to the power of 1, but instead of b, I'm going to substitute in that 3 that we just found. So 6 equals a times 3 to the power of 1. So next thing I'm going to do is simplify this part, this 3 to the power of 1. That would just be 3. 3 to the power of 1 is just 3. So instead I could have this as 6 equals 3a. And then to solve this equation, this should be pretty recognizable. We're going to need to divide both sides by 3 to cancel out that 3. And that would give me that a equals 6 divided by 3 is 2. And now I know both of the numbers that I need for this function. All we're looking for is a and b. So we're going to use this function y equals a b to the power of x, where a is 2, b is 3, and I'm going to put that in parentheses, because if I don't, it'll just look like 23. So we're going to put 2 and then the 3 in parentheses. To the power of x. And that is the function. So that's our answer for this one. So this is what we're going to be doing for all of these problems, is we're going to Make these functions, divide them by each other, and then substitute in the values for a and b that we get. So for number 2, we have our 2 points that have x and y values. Again, we're going to start with the second point, and so that's going to give me 24 is the y value, equals ab to the power of 3 is the x value. The next equation, we would have 12 is the y value for the first point, equals ab to the power of 2. Once we have our 2 functions, we're going to divide them by each other. So 24 divided by 12 is 2. The a's cancel each other out. And b to the power of 3 divided by b to the power of 2. Can we subtract the top minus the bottom? So that would give me b to the power of 1, or just b. So we have 2 equals b, or I prefer it as b equals 2. And then we're going to substitute that back into one of these equations. Again, it doesn't matter, but the smaller exponent will be easiest to work with. So I'll do the one that's 12 equals a, and then instead of b, I substitute in 2 to the power of 2. Now 2 to the power of 2 is 4. So I could write this as 12 equals 4a. And then to solve this equation, I need to divide both sides by 4 to cancel out that 4. 12 divided by 4 is 3, and so I will get a equals 3. And now that I know both b and a, I can put this into this function, y equals 3, and then in parentheses 2 to the power of x. So on to number 3, we're going to be doing the same thing. We have our 2 points. So we need to put them into the function. We start with the second point, so we'd have 32 equals a b to the power of 3. And then for the first point, we would have 2 equals a b to the power of 1. We divide the top divided by the bottom, so 32 divided by 2 is 16. The a divided by a would cancel out. And the b to the third divided by b to the first would be b squared, or b to the power of 2. Okay, so then we take the square root of both of these, and we would get b equals the square root of 16 is 4. Then we're going to put that back into one of these equations. I have 2 equals a, b we just found out is 4 to the power of 1. The 4 to the power of 1 is 4, so this would give me 2 equals 4a. And then, just like the other one, if we have 4a, we need to divide by 4 on both sides to cancel out this 4. In this case, when you do 2 divided by 4, you get 0.5, but we want this to be a fraction, not a decimal. So if you have 0.5, what you need to do is hit math on your calculator, and then hit enter twice, and that'll give you the fraction 1/2. So a is going to equal 1/2 for this problem. But now that we know a and b, we can write the function y equals 1/2, and then 4 in parentheses to the power of x. Okay. So last one for our notes is we have the point 216 and then the point 52. So we start with the second point first. We'd have 2 equals a b to the power of 5. And then for the first point, we would have 16 equals a b to the power of 2. So we're going to divide these by each other, the top divided by the bottom. For the 2 divided by 16, that's going to give you another decimal. So again, you need to do that math, enter. But 2 divided by 16, when you turn it back into a fraction, will give you 1/8. The a divided by a, again, cancels out. And the b to the 5th divided by b squared would give you b to the power of 3. Because, again, you take the top minus the bottom when you're dividing variables. So now that I have b to the power of 3, I need to solve this by doing not the square root, but the cube root of both sides. So it looks kind of like taking the square root, but there's that little 3 on there to show that it's taking the cube root. Okay. Now to find the cube root on your calculator, you need to hit math and then 4. That'll give you the cube root. If you wanted to do like a 5th root or a 4th root or anything higher than 3, you would hit math and then 5. But for the cube root, you hit math and then 4. So the cube root of 1/8, again, you want it as a fraction. That'll give you 1/2. So b is going to equal 1/2. So now we're going to put that into this function. 16 equals a, and then b is 1/2 to the power of 2. We're going to put this into our calculators to simplify that. Again, we want it as a fraction, so 1/2 squared would give me 1/4 a. Now when we have a fraction here with our equation, there's kind of 2 ways we can solve it. One way is we could divide it. So we could divide by 1/4 on both sides to cancel out that 1/4. But for me, dividing by a fraction is a little funky. So what I like to do is instead, I like to multiply both sides by the denominator, by the bottom part of the fraction, in order to cancel out that fraction. So I'm going to multiply both sides by 4, because that cancels out the 1/4. And that would give me that a equals 4 times 16, which is 64. So then using a and b, we get the equation y equals 64 times 1/2 to the power of x. So that is all for this video, for this section of the notes. Make sure you are reading the whole Canvas page to make sure you are doing everything that you need to do today in class. Remember to take your packet home and bring it back to school on both Thursday and Friday, because tomorrow you're going to be working on the review, and then Friday will be your test. So make sure you're doing good work so that way you are ready for the test on Friday.